Good morning to everyone, and today we are going to discuss about 8086 microprocessor, its introduction and architecture. Okay, so today's agenda is first one is introduction 8086 microprocessor, architecture of 8086 microprocessor. Then third one is BIU and EU, bus interface unit and execution unit. Then fourth one is registers of 8086, then ALU, arithmetic logic unit, and then finally the last one is queuing of instruction in 8086. Okay, so first we can see about the architecture of 8086. Okay, so before going for that, we all should know the basic about the 8085, which is before one of this 8086 architecture. Okay, so what is the main difference between 8085 and 8086 architecture is 8085 means that is time consuming architecture, and this one is by using this 8086 we can able to save some amount of time. So for that purpose we go for this 8086 microprocessor. Okay, so this 8086 microprocessor is a 16-bit microprocessor, so it works in 16-bit, and the arithmetic operation which we take place in microprocessor 8086 is 16-bit. Okay, so here we have 16-bit data bus and 20-bit address bus. Okay, so we can able to store 1 MB of memory in this microprocessor. Okay, so this is the introduction of 8086 microprocessor, and now we are going to see the architecture of 8086 microprocessor. Okay, so this is the diagram of 8086 architecture. So when we are looking into this diagram, we can able to know this microprocessor architecture is divided into two. Okay, so one is BIU, the top one is BIU, the dotted portion, the bottom one is EU. What is BIU? BIU is nothing but bus interface unit, and the second one is EU. EU means that is execution unit. Okay, so here we have two sections: bus interface unit and execution unit, and all the operations, arithmetic operations, will happen in this execution unit. Okay, so here we have memory interface, then some blocks like instruction stream byte queue, control system, then arithmetic logic unit. Here the arithmetic operations of 16-bit will happen over here. What is the arithmetic operation? Arithmetic operation is nothing but addition, subtraction, multiplication and division. Okay, so we are going to give the instruction, and this arithmetic logic unit is going to perform the addition, multiplication, subtraction and addition. Okay, so if you want to perform add, addition, so we give the instruction like add BL comma CL. So these two registers will be added in this arithmetic and logic unit. Okay, so here we have two sections: BIU, bus interface unit, and the second one is the execution unit. Okay, so we can study one by one. First we can see about bus interface unit. Okay, so before going for that, so what is microprocessor? So what is the operation of microprocessor? So what is use of microprocessor? We have to study that. Okay, so microprocessor, it is nothing but it is a processor. It processes the instruction. Okay, it processes the instructions. We are going to give the instruction, we are going to type the instruction, and the microprocessor is going to process the information. Okay, so BIU, it fetches the data. Okay, BIU, it fetches the data from the programmer, and the control system, it decodes, and then the ALU, it takes the instructions from the BIU. Okay, so BIU, it fetches, then it keeps the information inside the processor, then it executes. Okay, so what is the purpose of BIU? It fetches the data. Okay, so what is the purpose of EU? It executes the data. Okay, so BIU, it fetches, and the control system, it decodes, and finally the decoded value is given to the execution unit for the execution of the instruction. Okay, so this is the general description of microprocessor. So the main difference between 8085 and 8086 is 8085 means the processor fetches the data, then it saves the data in the microprocessor, then it executes the data, then finally it produces the result, that is 8085. Then again it fetches the data, then it executes, and finally produces the result. Once the complete once the cycle is completed, then again it fetches the data, then execute, and then completes the instruction. So this cycle still goes on. So in 8086 the thing is different. It fetches the data, then it decodes and go for execution. While it is executing, it fetches the next data simultaneously. So here execution and fetching will happen simultaneously, so we can able to save the time. So there is a main difference between 8086, and we call it as pipelining. Okay, we call it as pipelining technique. Okay, so now before studying the architecture, we have to know about the memory. Okay, so here we are going to study the memory segmentation. So this is a memory. Assume we have taken 1 MB of memory. So it is segmented into 4 types. First one is core segment, stack segment, data segment, and extra segment. Okay, so core segment, it has the program, and stack segment, it has the stack, and data segment, it holds the data of the operations, and finally the extra segment. Okay, so here we have uh, segmented address and offset address. Segmented address is the starting address of each segment. Okay, segmented address is the starting address of each segment, and the offset address, I mean the uh, offset address, it moves on going to the next state, that is called as offset address. Okay, so this is the memory segmentation. So why memory segmentation is needed means we can able to retrieve the data from the memory easily. Not only we, the computer, it retrieves the data easily from the memory. So for example, consider a 1 TB hard disk. So it has 1 trillion spaces. Okay, so small spaces, like 1 trillion spaces. So if you want to save something and you have to retrieve, we give some folder names and file names. So by using that folder name and file name, we can able to retrieve the data from the 1 TB hard disk. But what the computer, or what the system, or what the processor do is, it saves the data in the memory by using some physical address. Okay, it saves the data in the memory by using some physical address. So by using that physical address, the processor will retrieve the data from the memory. Okay, so that is not the virtual address. Virtual address means there is folder name and file name. So as a programmer, we use the folder name and file name for retrieving the data, and the processor, it uses the physical address for retrieving the data from the memory. Okay, so physical data means that is 0 ones, that is, we call it as opcode. So this is a memory segmentation. Another one example, for example, if we have a book, the book has 1000 pages and 10 chapters. Okay, the book has 1000 pages and has 10 chapters. Each chapter has 100 pages. Okay, so if you want to identify the page number 564, then we can easily go for chapter number 5 and page number 64. So here also the same as code segment. So the memory is divided into 4 segments: code, stack, data, and extra. So here these segments are called as the segments we can assume as a chapters in a book. So by using these, we can able to easily retrieve the data from the memory. So for that purpose, we are going for this segmentation. Okay, so this is a memory segmentation. The data will be stored and retrieved. So first one is code segment, stack segment, data segment, and extra segment. So here the address will be CS for core segment, SS for stack segment, DS for data segment, and ES for extra segment. So here the offset address for core segment will be IP, then for SP and BP for stack, and SI for data, and DI for extra segment. Okay, so this is about memory segment. So this one is the memory interface. So in the memory, the data will be stored in the memory, not data, the instructions. Okay, the instructions will be stored in the memory. Now this arithmetic unit will fetch the data from the memory for processing the address. Okay, so here when we are observing the architecture, each and every block are in rectangular shape except the arithmetic logic unit and this arithmetic progressor. Okay, so except these two things, everything are in rectangular in shape. Okay, so once you see the arithmetic logic in this shape, what is the use of this? It does the arithmetic operation like addition, subtraction, multiplication or division. We use this block. Okay, so once you find this block, it does the arithmetic operation. Okay, so here in this architecture we have two blocks like that. One in the bus interface unit, that is for calculating the physical address from then one another one in the execution unit, that is used for calculating the arithmetic operation, for doing the arithmetic operations. Okay, so here we have three different types of buses. One is address